Okay, let's go ahead and get started with Unit 2 by beginning with Lesson 2.01, Surface Area and Volume. And I just want to let you know right up front that Unit 2 is pretty much an extension of everything that we learned in Unit 1. And so it ought to be pretty easy. It ought to be just a little bit of material building up upon itself. Our objectives: to use formulas to calculate the surface areas of right rectangular prisms and cubes, and use formulas to calculate the volumes of right rectangular prisms and cubes. Please remember to always tell me your course number and section number whenever you're communicating with me. For example, 202B Section 2. Okay, I need that information to help you quicker. Some of the terms that we're going to be talking about today are a cube, it's a right rectangular prism on which every face is a square, and surface area and volume. First, we're going to talk about the right rectangular prism and its surface area, and just remember that it's the sum of the areas of all 6 sides of the prism. And so when this prism right here is laid out as a net, it's going to look like this. And there's 1, 2, 3, 4, 5, 6 sides, and you're going to be finding the area of each side and adding them together. And remember, we were using that capital L and doing all the figuring and adding. Well, they're showing us a new formula that we can use that can make it go a little bit quicker, which is surface area equals 2 times the length times the width plus 2 times the length times the height plus 2 times the width times the height. Then we're also going to be talking about volume, and I could have gone in and corrected this and completely forgot to. So this right here should not say surface area, it should say volume. I'm crossing that out really good, and I'm going to put up here volume so we don't forget that that's what we're talking about here. Your volume is going to be the amount of space inside a right rectangular prism measured in cubic units. Okay, and here's your formula that you're going to use. Volume equals length times width times height. And the best way to learn surface area and volume is just to practice. So that's what we're going to do. It says you are wrapping a gift for a friend, and the box is in the shape of a right rectangular prism whose dimensions are 14 inches by 11 inches by 7 inches. You have 625 square inches of wrapping paper available. Will this amount be enough to wrap the gift? Explain why or why not. Well, first you're going to pull out your old handy dandy formula that you just learned about for calculating the surface area. Then you're going to determine what are we going to allow to be our length, what's going to be our width, and what's going to be our height. And in this problem we let 14 be the length, the width be 11, and the height be 7. So what we're going to do is we're going to take these numbers and plug them into this formula. And there we go. So after we calculate the surface area, we find out the surface area of the box that we're using is 658. And remember, we only have 625 square inches of wrapping paper. So that means that we don't have enough wrapping paper to take care of this box. Okay, we're going to need a little bit more. Here's another example. It says find the surface area and volume, and we're going to do this right rectangular prism. It's going to be really easy to plug in the numbers this time. We've got the formula for the surface area of the prism, and we're going to let the length be 9, the width be 7, and the height be 6, and we're going to take these numbers and plug them into that formula. There we go. When you do the calculations, please use your calculator. You're going to find out that the surface area of the prism is 318 inches squared. And we're basically fixing to do the same thing for the volume. We've got our formula, volume equals length times width times height. We're going to let our variables have the same numerical value. Length is 9, width is 7, height is 6. And when we calculate that, we find out that the volume is 378 inches cubed. Okay? And next, we didn't really talk about them much because there's not that much to talk about with a cube. So with what we're going to talk about in cubes in this lesson, it's just easier to show you these shortened formulas that you can use for cubes. You can use this surface area formula and this volume formula for cubes, okay? Or you can use these shortened formulas. Either one is going to get you the same information. And in this example, we're finding the surface area and volume of this cube whose each edge equals 5 centimeters. So, to find the surface area, we're going to let S equal 5 because that's what they told us in the problem. And then we're going to take that 5 and we're going to plug it into this formula right here, 6S squared. So remember, you always do exponents in your order of operations before you do the multiplication. So 5 squared is 25. 25 times 6 is going to give you 150. So the surface area of the cube is 150 centimeters squared. Now to find the volume, we're still going to let S equal 5 because that didn't change. We're going to plug the 5 in for S in the volume formula, and then we're going to cube it, which gives us 125. So the volume of the cube is 125 centimeters cubed. See, it makes it a little easier to do the math when you use these shorter formulas, but let me state again that when you use the longer formulas, that your answers will be the exact same. On this next example, it says a toy company creates a model of a huge puzzle cube by stacking smaller toy puzzle cubes. Each side of the model measures 6 feet. So first off, let's note that it's a cube. I like to highlight this kind of stuff or underline it. It's a cube, and each edge of the cube measures 6 feet. Okay? So that's going to help us answer our questions. A, what is the surface area of the model? So first, if we're going to do surface area, we need to identify our formula. Well, remember, we can use that long one for the rectangular prism, or we can use this shorter formula for a cube. This should be a 16. No, it's a 6. I'm sorry, it's a 6. I don't know where I was getting 16. It says each side of the model measures 6 feet. So we're going to plug 6 in for S. Okay, and you're going to square 6 times 6 is 36, or 6 squared is 36. 36 times 6 is going to give us 216. So the surface area of the model is 216 feet squared. Now remember, for finding the volume, because it's our next question is what is the volume of the model, we're going to use this formula for a cube. Volume equals S cubed. So we're going to plug in 6 for S, and we then actually up here we know what 6 cubed is. Okay, it's going to be 216. So the volume is 216 feet cubed. And now the surface area and the volume being the same is coincidence. It doesn't always work out that way. Okay, so what have we learned today? Use these formulas for figures in 3 dimensions. The surface area of a right rectangular prism, you're going to use this formula. And for the volume of a right rectangular prism, you're going to use this volume formula. We also learned that a cube is a right rectangular prism whose length, width, and height have equal measures. And remember, when you're finding the surface area and volume of a cube, you can use these formulas, these longer ones, or you can use these shorter versions that we just went over in the examples. Okay, either one of them's fine.